If tonight, while you're asleep, the moon suddenly disappeared, how long do you think humanity could survive? A year? A month? Or just a few days? The answer is far more terrifying than you imagine. Because humanity would not die from darkness. We would die because the earth would go insane. The oceans would revolt. The climate would spiral out of control. The planet's axis would begin to wobble like a spinning top with no hand to steady it. This is not science fiction. This is a scenario seriously calculated by physicists. The moon is not just something hanging in the sky for decoration. It is the brake, the stabilizer, the shield of Earth's survival. And the most horrifying part is this: the disaster doesn't begin when you stop seeing the moon. It begins in the very first second you can still see it. The most unsettling thing is this: you wouldn't feel anything at first. When the moon disappears, it doesn't vanish from your eyes immediately. Moonlight takes about 1.3 seconds to travel from the moon to Earth, which means that in the exact moment the moon is truly gone, the moon you are still looking at is already a ghost, an image from the past. For 1.3 seconds, you can still admire its familiar glow while the catastrophe has already begun. Then, about 10 seconds later, something fundamental breaks. The moon's gravity disappears. Not slowly, not gradually, it is simply gone. For billions of years, an invisible hand has been pulling on Earth's oceans every single second. That hand suddenly lets go. The water doesn't drain away. It doesn't explode upward. Instead, the oceans lose their sense of direction. Tides that once followed a precise rhythm, rising and falling like a heartbeat, collapse into chaos. Scientists estimate that more than 2/3 of Earth's tidal force comes from the moon. The sun contributes the rest, but it is far too distant to control such massive volumes of water. Without the moon, the oceans hesitate, then begin to move in ways they never have before. No pattern, no schedule, just immense bodies of water searching for a force that is no longer there. And this is only the beginning. Because when the oceans lose their rhythm, the planet itself is about to lose control. Within the first 24 hours after the moon disappears, Earth's oceans are no longer the oceans we once knew. Scientists have calculated that more than 2/3 of Earth's tidal force comes from the moon. The remaining portion comes from the sun, but the sun is simply too far away to control such an immense volume of water. When the moon's gravitational pull suddenly vanishes, the tides do not stop. They shatter. Instead of rising and falling in their familiar rhythm, the oceans begin to oscillate chaotically, like water in a colossal bathtub that has just been violently shaken and then abandoned. Strange waves start to appear from directions no one expects. These are not classic tsunamis moving along a single axis, but erratic surges and retreats, repeating again and again, unpredictable, patternless, and relentless. Within hours, coastal cities around the world enter a state of red alert. Ports shut down. Coastal defenses lose their effectiveness. Areas once considered safe are suddenly flooded, then exposed, then flooded again. But the danger does not stop with humans. Millions of organisms that depend on tidal cycles, crabs, shellfish, coral reefs, and other coastal species, suddenly lose their biological clock. They no longer know when to feed, when to reproduce, or when to hide. Within months, entire tidal ecosystems begin to collapse in a chain reaction. And here is the truly alarming part. Around 29% of the world's population lives within 50 kilometers of a coastline. That means the food supply of billions of people is now under serious threat. But this is only the opening act. After 1 year without the moon, Earth begins to reveal a truth few people ever realize. The moon does more than create tides. It acts as Earth's silent brake. For billions of years, through tidal interactions, the moon has been steadily draining Earth's rotational energy, slowing the planet down and keeping it stable. Because of this long-term braking process, a single day on Earth now lasts 24 hours. But when the moon disappears, that break is suddenly gone. Earth does not explode. What happens is far more dangerous. It begins to lose its balance. Right now, Earth's rotational axis is tilted by about 23.5 degrees. This stable tilt is what gives us 4 seasons and a climate gentle enough for life to exist. And the reason this tilt remains stable is the gravitational influence of the moon. Like a spinning top, there is always an invisible hand keeping it upright. Without the moon, Earth's axis begins to wobble violently. Scientific models suggest that the tilt could fluctuate dramatically, ranging anywhere from 10 to 45 degrees. What does that mean? It means the seasons lose all control. At certain times, the North Pole could tilt directly toward the sun, turning it into a scorched desert. Meanwhile, the equator could fall into prolonged darkness, covered in ice and snow. Then, a few hundred years later, everything could reverse. Climate shifts this extreme are something no living organism can adapt to. The last time Earth's axial tilt changed significantly, by only 1 to 2 degrees, it was enough to trigger mass extinctions in Earth's history. So what would happen if the tilt changed by more than 10 degrees? The answer is simple: a planetary hell. And this is only the first year. 100 years after the moon disappears, Earth no longer resembles the planet we once called home. By now, Earth's rotation has begun to change. Not abruptly, not dramatically in a single moment, but slowly, relentlessly. And on a planetary scale, even the smallest change is catastrophic. As Earth spins faster and less steadily, the entire atmospheric circulation system breaks down. Air no longer moves gently from equator to pole. It accelerates. Winds grow stronger year by year, feeding storms that no longer follow familiar patterns. Today, the most powerful winds on Earth reach around 80 meters per second. In this new world, ordinary winds begin to approach 200 meters per second. At those speeds, trees cannot stand, soil cannot remain in place. Oceans tear the air above them into permanent storms. If Earth's day were ever shortened even further, wind speeds could exceed 500 meters per second. At that point, wind is no longer weather. It becomes a planet-wide weapon. Concrete structures crack and collapse. Steel frameworks twist apart like paper. Nothing built by human hands can endure. And no organism can survive in an environment where the air itself is violent. There are no stable forests, no permanent oceans, no calm skies, just endless storms scouring the surface of the planet. Earth does not explode. It does something far worse. It becomes a world where life has no place to exist. A planet still spinning, still illuminated by the sun, but fundamentally no longer habitable. There is one role of the moon that very few people ever think about. It is Earth's asteroid shield. Take a close look at the moon's surface. It is covered with impact craters, large and small, overlapping each other. Those craters are not decorative. Each one is the scar of a collision the moon took on behalf of Earth. For 4.5 billion years, the moon's gravity has attracted countless asteroids and meteoroids, pulling them toward itself before they could strike our fragile blue planet. If the moon disappears, that shield disappears with it. Earth would be left fully exposed to the constant bombardment of space debris. Yes, Jupiter, the giant of the solar system, does help deflect some large objects with its immense gravitational pull. But Jupiter is too far away to protect Earth from every threat. The moon is Earth's closest line of defense. Remember what happened 66 million years ago. A single asteroid, roughly 10 kilometers wide, was enough to wipe out the dinosaurs and reshape the entire course of life on Earth. Without the moon, impacts like that would no longer be rare events. And in a world that has already lost its stable climate, its calm oceans, and its gentle skies, it would take only one strike from space to bring everything to an end. But the moon's importance is not limited to preventing disasters. It may also be the key to the birth of life on Earth. Billions of years ago, when Earth was still a young planet, its primordial oceans were almost motionless, quiet, and low in energy. It was the tidal forces created by the moon that stirred those early oceans, allowing nutrients to circulate and giving primitive chemical reactions a chance to occur. Most importantly, the intertidal zone, where water rises and retreats each day, became a bridge between sea and land. Here, early life forms learned how to survive dryness, endure sunlight, and eventually